Exercise 325, applying the ratio test. I've copied over the terms of the sequence. Looking at this form of the terms of the sequence, I can see the explicit dependence on n. To write down the next term in the sequence, I simply need to replace out n with n plus 1. When I replace out n in the numerator, I'll get n plus 1 quantity factorial, and that's the same thing as this expression. Replacing out n in the bottom, I'll have a quotient n plus 1 over e raised to the n plus 1. I can then factor off one copy of the n plus 1 over e and leave n plus 1 over e raised to the power n. Both of these expressions are positive valued. So when I express out the absolute value of their quotient, I don't need to carry over the absolute values. Taking a quotient of two quotients is more easily computed as the numerator multiplied by the reciprocal of the denominator. So an is appearing in the denominator, and its reciprocal is take its denominator, write it in the top, its numerator, write it in the bottom. Good. Let's look for some cancellations. Let's take n plus 1, place it over n plus 1. This e is the reciprocal of e, so that comes to the top. N factorial, we can place it over n factorial. N to the power n appears in the numerator. N plus 1 to the power n appears in the denominator. And then 1 over e to the n is in the top as well as in the bottom. Nice. Each of these is equivalent to 1. E is the same thing as e. And then n over n plus 1 is equivalent to the reciprocal of n plus 1 over n. So this and this are the same. Then to go from this to this, we're simply swapping the powers. Nice. So this has made it easy to identify that it will limit to e to the negative 1. Inside will limit to e, and then this is being raised to the negative 1, so that's e to the negative 1. And e times e to the negative 1 is 1. And in the ratio test, that is the borderline case where the ratio test provides no information. Beautiful.